All right, guys, we're gonna get started with our next amazing speaker. I just absolutely love, totally biased, sorry guys, women in security. And with that, I'd like to introduce you to Anmol. She's gonna be sharing. She's gonna be sharing a bunch of stuff soon as we hook up the HDMI. And we love this industry that we're in, don't we?
It just takes a second.
There we go. There we go. All right, with that, take it away, lady.
All right, thank you. Just a sound check, and then everyone hear me. Okay.
In the back,
Okay.
how about the guy in the hat? All right.
All right. So today I'm going to be talking about an introduction to adversarial machine learning. So I'm a security researcher at Nokia. I specifically work in AI and machine learning security. So I have a doctorate in cybersecurity analytics. So this topic was basically my research area. Today, I am speaking as myself and not as as a representative of my employer. So, first, we need to understand what AI and machine learning is, and we kind of touched on this on the keynote, but just to recap, AI and machine learning are different concepts. So AI is artificial intelligence, and it enables you to perform human-like tasks. However, machine learning, it's a part of AI, but it's not AI. It's basically when a computer determines whether the input data and the output data are correlated or not. So a classic example of machine learning is we try to figure out whether an image is of a dog or not. Let's say our machine learning model learns that this is a dog. Then of course, with this image, it also thinks that this is a dog too. Now, why does it think this? Well, because it has similar features. You know, we can obviously see as humans that these are both dogs. But what does the machine learning model do? It sees that these images are very similar to each other. They both have eyes, a nose, a collar, a tongue sticking out. But what else is similar? Anyone have any ideas? Go ahead.
They're both on a bench or something.
Correct. They're both on a bench in sunlight. Yes?
The background is full of leaves.
Yes, that's another similarity. So the machine learning model is going to look at all of these similarities, not just at the fact that they're dogs, to conclude that these are both similar images. So now, show of hands, who is familiar with machine learning? Okay. So there are some who aren't, but I'm going to basically go over the basics of machine learning for those who are not. So I want to explain that machine learning has two phases, a learning phase and an inference phase. So the first phase is learning. This is when we train the machine learning model. And this is when the machine learning model discovers patterns with data. Here, in this diagram, I show you that you give the model training data, then you break up the training data into different features, or creating a features vector. Now, what is a feature? Well, as humans, we think of features being different parts of the image, and yes, that is true. But in a machine learning model, features are actually pixels of your image. So then, these features or pixels are given to the machine learning algorithm. This algorithm is basically the heart of machine learning. This is when we decide whether these pixels correspond to a certain result or not. And then the results are correlated into a machine learning model. So typically in machine learning, this has to be done many, many times in order to determine a proper result. Once the machine learning model has been trained, we have a inference phase or the testing phase. So this is when the machine learning model infers what new or unseen test data could be. In this case, test data is unseen in the sense that the model was trained on training data, but then it's tested on new data, the test data. Then again, the data is broken up into different feature vectors. Then it's given to the model, and then the model outputs a prediction by looking up what pixels correspond to which result. So typically, as I mentioned, this repeats many, many times in order to get a proper result. So machine learning, as we know, and we've probably heard of, is used for many different tasks. It's used in cybersecurity for anomaly detection. It's used for recommendation systems, image recognition, etc. Now, what am I talking about? Well, this is adversarial machine learning. So machine learning can be attacked. Okay, so adversarial machine learning comes into play because machine learning can be attacked. Now, I have a question for you. What is adversarial machine learning? Anyone have any ideas? Yes.
I'm gonna guess based off the picture. You could use learning for attacks. It's like trying to deliberately mess with machine learning process.
Yes, that is one way. So you can deliberately mess with the machine learning learning process. Yeah. Any other ideas? Yeah, go ahead. Yeah, getting the AI to output things it's not supposed to. That's another thing. So adversarial machine learning is a task, but it's also the study of how to defend against these kinds of attacks. So the attacks can attack both at the learning phase and also at the inference phase. So in this talk, I'll go over some of the attacks that can occur. So first, I want to emphasize why it's important to learn adversarial machine learning. So we're starting to rely on machine learning for many different industries, the medical field. But if machine learning is attacked, then there could be disastrous consequences. So specifically, let's say in the medical field, it outputs something and it says that a patient doesn't have cancer when in fact the patient does. Then, that is life-threatening. So it's very important to understand this concept. So now I'm going to go over the different types of adversarial machine learning attacks that can exist. So the first type of attack is the poisoning attack. This is when we inject bad training data into the model. And another way is you can insert a backdoor into the model, and then basically the model will output incorrect results because it's learning incorrect information. Then membership inference is when you infer the private training data by observing the output. Property inference is similar, but it's when you can determine properties based on the output of what you see. And then model extraction is basically when you're stealing the machine learning model. And the evasion attack is when the model is sent contaminated input. This is called an adversarial example. This is designed to cause the misclassification. So now let's go over these attacks in more detail. The first type of attack is a poisoning attack. In this attack, an adversary changes training data or data labels to cause the machine learning model to misclassify samples. There can be two types of poisoning attacks. One on availability to cause a denial of service attack, or on integrity. So here's a simple example going over the poisoning attack on availability. So here in this diagram, I show you that we have a label of a dog and of a cat. And here, you might not be able to see this, but the dog is labeled as a cat and the cat is labeled as a dog. So that is, you're mislabeling both of these images, and then you send it to the model. And you're basically going to get an incorrect prediction because obviously it thinks a dog is a cat and a cat is a dog. So that's kind of a simple example. This is called a label flipping attack in the industry. The next type is a poisoning attack against integrity. So this is a research example. What this is showing you is you're mislabeling a stop sign. So here you see that the speed limit is represented by these red dots and the stop sign is represented by the green dots. What happens when we backdoor the stop sign and we label it as a speed limit sign? Well, that's what a poisoning attack against integrity is. That's a backdoor you're adding. So then the stop sign is labeled as a speed limit sign instead of as a stop sign. So that's concluding poisoning attacks. Any questions before I move on? Okay. So the next type of attack is the membership inference attack. In this attack, an adversary queries the model to see if that sample was used in training or not. So here, in this diagram, you see that we have two dog images. And then it says that one image is a dog and one image is not a dog. Well, from this, we can infer that the image, like the top image, was used in the training samples, but the bottom image was not. Maybe this means that the model was only trained on certain colors of dogs or certain types of dogs. So that's kind of how a membership inference attack would work. The next type of attack is a property inference attack. In this attack, an adversary examines properties of the training data set, even though those features were not used directly on the model. So in this case, the model is storing more information than is needed for its task. So let's say we're not only giving the model dog images, but we're also giving it location and owner information. Well, then maybe the model would be able to output certain locations, and then not only could you conclude that these dogs were used, but also maybe all of them are in California, or all of them are in Silicon Valley. So that could also be a privacy violation. So maybe you can make some inferences based on what outputs you observe. The next type of attack is a model extraction attack. Why do we care whether a model is stolen or not? Well, it's because it takes a lot of time, money, a lot of effort to create this machine learning model. If someone steals it, they can not only do this task as well as the model, but maybe even better. This is an intellectual property violation. It could also be a privacy violation because maybe you could perform a membership inference attack on that model. And then this type of attack is an evasion attack. This is when the model is sent an adversarial example, and that causes a misclassification. So the adversarial example is an input to the model, and it looks like it's a normal image, but actually it has been contaminated. So this is a classic example. What this is showing you is that the panda image, if you add noise to it, some kind of noise, then it will misclassify that image because this noise is confusing the model. So the machine learning model thinks that this is actually a gibbon, it looks like a monkey, instead of as a panda, because of this noise, because it sees these pixels, and that's why it gets confused. So I've talked enough about the research aspects. Let's look at some real life examples. The first classic example is Tay chatbot. How many of you have heard of Tay? Yes, yeah. So Tay is actually an example of a poisoning attack. So for those who don't know, Tay was a chatbot deployed by Microsoft to chat with 18 to 24-year-old people. It was supposed to basically emulate a teenager, and within 24 hours, the bot had to be shut down because it was training on Twitter data, social media data, and of course, it's the internet. What are people going to do? They're going to troll. They're going to send random stuff. So Tay started using offensive language about conspiracy theories because it learned these poison tweets. So if you contaminate the training data, the model will be impacted. The next example is poisoning VirusTotal. How many of you have worked with VirusTotal in the past? Yes. So VirusTotal is basically, for those who don't know, this poisoning VirusTotal attack occurred, and it's when a malicious actor started creating new malware files based on a popular ransomware family. Those new files were called mutants. So not all of these files that look like ransomware were actually ransomware. A lot of them didn't even work. But all of these mutant files were uploaded to VirusTotal, and vendors marked several of those mutant files as members of the same ransomware family, even though they did not actually work. So again, that's a poisoning attack. So this one is interesting. This is an invisibility cloak. This is something that was developed by researchers from Facebook AI and University of Maryland College Park. So this is what's known as an invisibility cloak. What it's showing you is if you were to wear this sweater, it can't actually recognize that a person is there. It doesn't recognize their face. Why is this? Does anyone have ideas? Yeah, go ahead.
Misclassification attack.
Yeah, it's misclassification. So specifically, this is an evasion attack. A sweater has adversarial examples on it. All of these objects you see. And so that is confusing the model, and it thinks that, you know, those objects do not correspond to something a person would wear. So that's basically the invisibility cloak that they're developing. So these adversarial examples are fooling that computer vision model. The next one is when researchers actually attacked Tesla autopilot. So this was research conducted by Keen Security Lab in 2019. And they demonstrated that researchers were actually able to remotely control the steering system, disrupt auto wipers, and also trick the Tesla car into driving in an incorrect lane. So here's one example. This is showing how the researchers basically added noise to the image. And even though it's not raining in that image, the Tesla model thinks it is because of this noise that's added. So then the wipers would start of the Tesla car, even though it's not raining. So that's one example of when Tesla was attacked. Here's another example. This is when Tesla basically was not able to recognize lanes correctly. So again, you see that the researchers added some noise, and that causes Tesla to basically have an incorrect result for their lane recognition system. They also tried adding stickers to their lane, and because of those stickers, the model was fooled and it couldn't recognize whether there was a lane or not. In case you're interested in reading the full report, I've put the link in the slides. You can look at it later. So this next example is when we attack Alexa using adversarial music. So typically we know when we say Alexa, Alexa is supposed to wake up and respond to our commands. But the researchers show that there can be an attack on Alexa by adding adversarial music. So let's see if the sound works. Yep. Let me try to just increase the volume. Hopefully. Okay, so it looks like the volume isn't working. So it looks like the volume might not be working on this video, but it's okay, I can talk to it. So here the researcher is basically saying the word Alexa, and that's it. It just says Alexa, and you notice that the Alexa device wakes up. Now later in the video, he shows how they add some music to it, and then Alexa does not wake up. So this music, it would have been nice for you to hear it, but it's basically slow guitar timbre sounds. So here he's showing that he's playing this music at 70 decibels, and this music is playing in the background, and Alexa is not waking up. So that's an example of adversarial music being added. So machine learning can be attacked in many ways, not just with images. So now how do we, yeah. Let's try that. Yep, so that's the music. If you play that music, Alexa is not able to understand the command Alexa. So now how do we actually mitigate adversarial attacks in the industry? Well, there are many open source industry solutions that are coming out. These are just a few of them. One is Counterfeit by Microsoft. This is an open source tool used to test the security of machine learning. So all these links, by the way, they correspond to the GitHub repositories for all of these tools. So after the presentation, you can try downloading these. So the second one is Adversarial Robustness Toolbox. This is a Python library to defend and evaluate machine learning. Model Scan is another open source tool by Protect AI. This is when the models are scanned to see if they're secure or not. So they basically scan the code and they see whether malicious code has been added to the model when it's being loaded to prevent the model from basically executing malicious code when it's deployed. Then finally, Adversarial Threat Landscape for Artificial Intelligence Systems, or ATLAS. If any of you have heard of MITRE ATT&CK, this is basically the adversarial machine learning version of MITRE ATT&CK. And it's basically a list of tactics and techniques used by adversaries. And then they have some real world case studies as well of some of these attacks. And this helps security analysts protect and defend systems. But like MITRE ATT&CK, it can only be used in a reactive sense, not in a proactive sense. You can only defend your systems once you know that an attack has occurred, and then maybe you can trace your steps. But you can't prevent the attack from occurring using the ATLAS matrix. So that concludes my presentation. This is a LinkedIn QR code if you want to get in touch afterwards. I'm open to questions if anyone has any. All right, thank you. I'll just leave this up for a few minutes.